Okay, so let's have a look at 9.1. So this is the second part of 9.1, exploring rational functions using transformations. So we're still looking at rational functions, so which means 1 over a polynomial of some sort or a different function. So we still have the same basic 1 over, let's say, q of x. Now here, all the same principles that we talked about in the previous lesson apply. What do you notice about x squared? What could it never be?
0.
It can never be equal to 0, right? So if I were to, let's say, choose a couple of x values to put in here, what do I notice is going to happen here? This is going to be 1 over 0, which is undefined, right? So what does that mean in terms of the graph here? How does this translate onto the graph? This is an asymptote, and it's going to be right along here, right? Now, since I can never make this equal 0 because this is going to be undefined, what else is going to be an asymptote? Right here. Okay. Y equals 0. Now, let's plot the rest of these points. So this is going to be 1 over negative 2 squared, 1/4. This is going to be 1 over negative 1 squared, which is 1. This is going to be 1, and this is going to be 1/4. So we'll just simply plot these points here. So at x equals negative 2, this is going to be at 1/4. At negative 1, this is at 1. And then this follows the pattern of it getting closer and closer to the asymptote on either sides. And then on this side, these points are just a mirror image. Okay? Okay, I'm going to turn my page over so that I can get a nice curve. Okay, and don't forget the arrowheads on the ends. All right, so what would you describe this shape as? A volcano, maybe? Yeah? Okay, sounds good. Let's go with that. Okay, so let's just make a note of the fact that the factor here of x has a multiplicity of 2. So the graph remains positive on either side of the asymptote. And what's my non-permissible value here? So what value of x is not allowed to be? So x equals 0 is my non-permissible value. My x-intercept here is what? So that's when y equals 0. So what do we have? So if I set y equal to 0 and solve for x, what do I end up getting? I end up getting 0 equal 1. That's not possible, right? So there's no x-intercept. And how about here? When, for my y-intercept, when x equals 0, what do we end up getting? We end up getting y equal 1 over 0, which is undefined. And then I say that there are no y-intercepts. And that's clear by the graph that we saw. So my vertical asymptote was 0, my horizontal asymptote was y equals 0, and my domain and range, my domain is x cannot equal 0, and my range is y has to be greater than 0. Okay. Okay. Now the next question we're going to look at, we actually did in grade 11. We did this in Pre-Cal 30S. And we talked about non-permissible values. And we also talked about invariant points. We talked about what happened when y is 1 and negative 1. Those were our invariant points. So you could remember all of those things. This was a question from PC40S. We factored it. What happened when we factored this? What did we end up getting? We ended up getting this right here. Now, what do we get? What does it tell us?
The points, the 0.
Okay, so if we were graphing, you know what? I'm going to call it f of x. I'm going to say f of x equals x squared. Sorry, f of x equals x squared minus 4. Let's say we were graphing that. This is going to have x-intercepts, right? This is actually going to look like what? This is going to look like, it's going to be down here. My x-intercepts are, if I factor it, that gives me my x-intercepts. And this is a parabola, right? Okay, so there's my sketch. This is a very rough sketch of what, this is x squared, minus 4. X squared minus 4. Now, in grade 11, in Pre-Cal 30S, how did we use this graph to create the sketch of 1 over x squared minus 4? What did the x-intercepts turn into? They turned into, well, what do you notice? What do you notice about, if you have x equal negative 2, what happens to this equation?
0.
You end up with a 0 in the denominator. Is that a good thing? No, that's a bad thing. Okay, so x cannot equal negative 2. If you have x equals 2 here, what do you notice happens? You get another 0 in the denominator. Is that good? No, that's bad. So x cannot equal positive 2. So what happens to our x-intercepts of our parabola? They become asymptotes. That's right. Okay. So that's where we get our asymptotes from. Now, do you remember invariant points at all?
Yeah.
Okay. Now, the thing about invariant points are, if we were to solve 1, positive 1 or negative 1 equal to x squared minus 4, we will get the same x values as if we were to, as if we were to solve for plus or minus 1, minus 1 over x squared minus 4. Okay? Now, you can take the time later and prove that to yourself, because we did that last year. All right? I just want to remind you quickly of that this year. So what we can do is really just look at where y equals 1, and you're going to look at where the original parabola is, and just mark an X at where it runs into. So, and then you're going to do the same thing for when y equals negative 1. Okay? So over here, y equals negative 1. You're going to run X, you're going to run a mark a point there as well. Yes, question?
How do we find those points without drawing in the parabola?
I didn't draw this parabola in perfectly. I just knew that the x-intercepts were here and here, and my y-intercept was here. I just estimated the shape based on that information.
So, like, how do you know which side the points are on?
All I need to know is where in the quadrant it's in. I don't need to know,
Okay.
I don't need to be so precise, okay? I just need to know that the points are gonna be in this quadrant as opposed to here, okay?
Okay.
Okay. Now, I also need to know where this point ends up going. So this point in the parabola is -4, right? Now I'm graphing 1 over x squared minus 4. So what happens to this point? This ends up becoming -1/4. So if I were to take x equals 0 and plug it in here, then I end up with 1 over -4, right? So this point ends up here. Okay, so I end up with this general shape. I connect these three guys together. So this is where,
If it's negative, would that be at the top and then?
yeah. So this gives you the idea, the general shape of where everything is. And so then you could just erase.
If we wanted to find the points, could we just plug in numbers from the quadrants and then?
Yeah, if you wanted to find the points, if you didn't want to use this graphing method, then you could simply just take x values. You could just take in x values. You could say plug x equals -3. Plug x equals -3 into here. Plug x equals -1. Plug x equals 0. Plug x equals +3. You could just plug points into the original equation, make a table of values, plot points, and go.
Is there a horizontal asymptote of 0?
There is definitely a horizontal asymptote right here. Yeah. Oh, sorry. Right there. Okay. So what's our non-permissible value here? -2 and 2. What's my x-intercept here? There is no x-intercept. What about my y-intercept? -1/4. How about my vertical asymptote? -2, x equals 2. My horizontal asymptote? Y equals 0. My domain? X cannot equal -2. X cannot equal 2. And my range is Y cannot equal 0. Okay?
Like that's it.
Yeah, that's it. Yeah, and so if you want to take the points and you want to just plot them with a table of values, that's fine too. But this reminder, this is just something that you've already learned how to do last year. You can totally just use it again.
Ms. Cox?
Yeah.
I don't remember why do we have to use -1 + 1 to find the.
Okay, so I'm going to hit pause here. And then I'll do the next question on a